Hi everyone. Today we're going to be talking about lesson 7-4, find area of polygons. Now, the past three lessons we've been finding areas of polygons all along because if you look over here on the right, it says a polygon is a plane shape, which means two-dimensional, with straight sides. So when we were finding the area of parallelograms, those were polygons. When we were finding the area of triangles, those were polygons. And when we were finding the area of trapezoids, those were also polygons. Today we're going to talk about irregular polygons. I'll add an S there. If you look over here on the left, or you can look at page 405 in your book if you want to look along in your book as well, that's an irregular polygon. And you may look at it and wonder, why is it called irregular? Because I don't really have a good name for it. All the sides, or a lot of the sides, are different sizes. I could see, they count the number of sides, but if you were to show that shape to someone, say, what shape is this? I wouldn't call it a rectangle. I'm not going to call it a triangle. There's no set shape for it. We could count the sides 1, 2, 3, 4, 5, 6. It'd be a type of hexagon, but it would be an irregular hexagon because it just doesn't look normal. But today we're going to find the area of it. Now, for these irregular polygons, there's not going to be a formula for the polygon. And we're going to kind of do this the same way we're figuring out the area for trapezoids. So when I look at this, I want to see how I could break this up into different shapes that I know how to work with. And I know how to work with parallelograms. I think I made a mistake spelling that. I probably did. Yes, I did. Let me try that one again. And I know that is area equals base times height, and I know how to find the area of triangles. And that is area equals 1/2 base times height, or base times height divided by 2. So when I look at this, I don't see any triangles, but I see I can split it up right here and make 2 rectangles out of it. Or I could split it up right there and make 2 rectangles out of it. That's kind of really however you want to split it up. That's up to you. I like it this way though. So first, I don't need this triangle formula anymore because I'm splitting it up into parallelograms. So I have 2 rectangles, or rectangles of type parallelograms. Why? Because it has 2 sets. There's one set, there's another set, 2 sets of parallel sides going onto it. So let me highlight that top. Actually, let's start with the big one first. So here I see a big old rectangle, and that's a type of parallelogram because of 2 pairs of parallel sides, and I want to find the area of it. So I see the height, and I see the height is 10. So I'm going to say area equals 10 times, now I need the base. You may think the base is 15. It is not 15. 15 only goes from right there on the right to right there, but I'm still missing that little gap. So I want to figure out the area from here to there. What is that? I'm going to kind of make it a tape diagram. If I look up top at that 15, I see 15 would end right at start at the right and would end right there. So at the bottom, this large section, I'm going to call that 15 inches. Now I'm wondering what that small little part is. And that small little part, if I look all the way up, I see something that's the same size of it, and that's 5 inches. Oops. Let me undo that right there. So I'm going to call this 5 inches. So that means the whole part of this side is 20 inches. So I now know that to that large rectangle, it is 20 inches. So I'm going to have 10 times 20, and that large rectangle is going to be 200 square inches. Now, that's not our final answer because I'm still missing that small rectangle up top. So let's see if we can find out the area of that. Again, it's area equals base times height, so let's call it rectangle 2. I see a base of 5 right there, so 5 times. Now, here's where it gets tricky because I'm missing a height. So I need to figure out what that height is. It is not 22, but I think I could use that 22 to help us. And here's how. I'm going to make a tape diagram going I'll make it even larger, all the way down there. And the whole thing from top to bottom is 22 inches. And this part, that bottom part, is, if I look over here, it is 10 inches. So I need to figure out how far it is from there to there. And remember, the whole thing's 22. So the whole thing is 22 inches. So I'm going to do 22 minus 10 because I need to find the missing part. I'm going to get 12. So that means this side right there is 12 inches. Or that question mark is 12 inches. And if I back up a little bit, I could see that 10 inches plus 12 inches is that 22 inches, which is the whole thing from bottom to top. So it's going to be 5 inches times 12, and that's going to give me 60 square inches for rectangle 2. So now I'm going to add our two rectangles together. I'm going to say 200 square inches plus 60 square inches will equal, the area is going to equal 260 square inches overall for the whole entire thing. So I broke that up into two rectangles. It's a little bit like a puzzle. There's going to be missing pieces to it, but we have enough clues to figure out what those missing pieces are. Let's look at another example. Here, if you look at page 406 in your book, if you want to follow along, it says, Denise is building a patio in her backyard as shown in the diagram. She needs to know the area before she orders patio tiles. What is the area of the patio? So when I look at this, and when you look at this right away, the first thing I notice, I see a rectangle in the middle. I'll shade that in. Let me actually do this. I'm going to keep that there. That's going to make my life easier. So I see a rectangle in the middle, and I want to start finding the area of that. Now, a rectangle is a type of parallelogram, and I'm going to call that rectangle 1, and the formula for that is base times height. So for rectangle 1, I see the base is 4, the height is 6. That one's pretty easy, so 4 times 6, and that's going to be 24 meters squared. But now I also have two triangles. Now, luckily for me, these triangles, they're exactly the same size. So once I find the area of one of them, I'll know the area for the other one as well. So for triangles, we have to remember the formula for triangles is, I'll just call it triangle 1. The formula is base times height divided by 2 is my favorite, or 1/2 times base times height. So if I look at this, I see the base is 6, the height is 2. So I'm going to do 6 times 2 divided by 2. That's going to give me 12 divided by 2, which just equals 6. So that's all going to equal 6. So I'm going to say triangle 1 equals 6 meters squared. So I'm going to need that. I'm going to need rectangle 1. But now I have the last triangle over here. Now it may be pretty obvious that this is the same size as the other triangle. There's no height over there, but I know the height should be the same thing that's right there. So it's 6 meters. So for triangle 2, again, it's going to be base times height divided by 2. So 6 times the height of 2 divided by 2, and that's going to equal 6 times 2 is 12. 12 divided by 2 is 6. So 6 meters squared. So now I add it all up. So 24 meters squared plus 6 meters squared plus another 6 meters squared, and that's going to equal 36 square meters for the entire patio for that problem. So again, we're breaking things up in parallelograms and triangles. Let's look at a different type though. This is a different type problem completely. It says the Robinsons are planning to resurface the path that surrounds their garden. What is the area of the path? So we just want to know the area of this path right there, because they need to buy stone or concrete or whatever they're going to buy just for the path. So they need to figure out the area to know how much to buy. So here's how we're going to do this. First, I see an outside rectangle going around right there, and I see an inside rectangle. To find the area of just the path, I'm going to find the entire outside rectangle. I'm going to pretend this whole entire thing is the path. And then I'm going to subtract out the garden out of it. So let's find the area of the entire thing. So I'm dealing with parallelograms here. So it's going to be area equals base times height. So I see the base is 8, the height is 7. So area equals 8 times 7, which is 56 meters squared, dealing with square meters. Now, that would be if the whole entire thing was one big giant walkway, but it's not. There's a garden in the middle. So now I need to find out the area of this garden and subtract it from that 56. So it's going to be, call it rectangle 2. It's still going to be base times height. I see the base is 4 meters, the height's 3 meters. So 4 times 3 is going to be 12 square meters. I'm not going to add them together. I don't need any. The 56 already includes the garden. I need to subtract it out because they cannot put concrete over the garden unless they want to kill every plant in their garden by putting concrete on it. So we need to do the large rectangle minus out that garden because we don't want stone there, we don't want concrete there, and we're going to get 44 square meters is going to be the walkway. So whenever they buy materials, they're going to say they need 44 square meters worth of materials for just the walkway going around that garden. Okay. Last example, it's very similar. This is a parallelogram that's not a rectangle. We want to find the area of just the blue section. So remember, parallelograms, 2 sets of parallel sides. There's 1, here's 2. That's what makes it a parallelogram, only this is not a rectangle. So still area equals base times height. Let's do the large parallelogram first, and we're going to treat this just like the garden one. Then we'll subtract out that inside parallelogram. Only they don't give me a base and height. I need to use this grid to figure out the base and height. So it looks like each space is worth 1 unit. So the base is going to be 1. Actually, let me do it this way. 1, 2, 3, 4, 5. The base of the large parallelogram is 5. The height, remember the height has to form a 90-degree angle. So it's going to go 1, 2, 3, 4. I'll make it dotted lines. So the height's 4. So it's going to be 5 times 4, which is 20. But now we want to subtract out that little inside parallelogram. So it looks like the base is 1, 2. And then the height is 1, 2 as well. So the inside, or parallelogram 2, is going to be 2 times 2, which is 4 square units. So now we're just going to take the whole entire large parallelogram and subtract out that little tiny inside one to get 16 units to the second power. And that's how we do those problems. Please look back at the video first if you need any help, or join live office hours using Zoom. If you're watching this for a different team, whatever your teachers do, reach out to them. But really try looking back at this video first. And again, you can look in your book on the pages to look at these examples as well if your book is home with you. You do your best. Remember, as long as you know the formulas for parallelograms and triangles, we can find the area of anything that you'll see with this problem or with this lesson. So thank you for watching. Do your best work.